Hi, I'm Chris Ralph, and hey, have you ever wondered what raw natural gold looks like in the rock? What gold ore looks like? You know, where do they recover all this gold that's mined in different places across the world? If you've ever wondered what raw gold ore looks like, then you've come to the right spot. You've got the right video, because I'm going to show you all kinds of specimens of rich gold ore and different kinds of gold ores from all over the world, together with some of the stories behind some of them. And some of the stories are kind of interesting just in and of themselves. Now, the people who worked in this building behind me way back in the day, back in the early 1900s, they knew what gold ore looked like. They knew what ore was, because that's an ore sorting house. They actually took rock from a mine here at Tonopah, Nevada, and they sorted it out, and they would put the waste in one pile and the good ore in another. You see, they sorted. This is some waste rock, and they got rid of that. This is the ore. They kept that. And you see the giant pile over there? That pile is actually the pile of waste that was left behind. And underneath that building, there was actually a train track that ran through there, and they could load up the train cars with the ore, and then they would take the ore to be processed at a mill, and the gold and the silver extracted from it. So let's get started now. We're going to start a series of slides, a slideshow, showing you all kinds of examples of what gold ore looks like, so that you can learn how to spot gold ore. Because the truth is, if you're someplace and you walk by some gold ore and don't notice it, it could cost you thousands, if not even millions of dollars. Because the guy who found this stuff here in Tonopah, who found this, he walked by here and he recognized that this was rich gold ore, or rich gold and silver ore. And he took it to an assayer, and the assayer didn't want to run it because he looked at it and said, this is just junk. And so, knowing the difference between gold ore and not gold ore and junk, leverite, stuff that you should lever right there, leave it behind, is important to know, especially if you like to be out in the outdoors and that sort of thing. So stay tuned. We'll go out and check out what gold ore really looks like. Here we go. Okay, so now we're going to take a look at a whole lot of different specimens of gold ore to teach you what gold ore really looks like. What does gold in rock in its native original state really look like? Well, we're going to take a look at a whole bunch of different examples and get a feel for that, and I'll try and teach you so that you too can get a feel for this. Now, look at what this guy's holding. He's holding a chunk of super rich gold ore. The gold, of course, is the metal, the yellow metal you can see, and the white is quartz. And quartz and gold are very commonly associated, but not always. And we're going to talk about that too. But this piece that this guy is holding, now you look at it, it's maybe the size of a good-sized cantaloupe, right? And cantaloupe weighs a couple of pounds. Well, this chunk of gold is going to weigh maybe 15 or 20 pounds, simply because gold is so very dense. I mean, literally, this guy, he's holding a smallish piece that fits in his two hands, and yet this is probably more than $50,000 worth of gold. And that's not from any specimen value, but merely the richness of the gold, and the amount of gold in the specimen that he's holding is going to be something, like I say, north of 50 grand US. Here's another specimen of gold, and again, the white material is quartz. This gold is much shinier, and it's in thin sheets. This is often called leaf gold, because of course leaves are thin and sheet-like. And so this is an example of leaf gold. It's also from Australia, just as the first specimen, the guy holding the specimen, that was from a recent find in Australia. This is some more material from that same recent find, only you can see this chunk is big enough that they had to put it on a pallet. It's not something that a guy could hold in his hands, and yet it's just filled with gold. The total find on this find that they made here in the last 6 or 8 months was reputed to be worth millions. I mean, literally, they found several $1 million worth of very high-grade gold ore like this, some of which will be sold for specimens, and some of which I'm sure will be crushed and the gold extracted from the ore and then melted down. Now here is a much smaller specimen. This is from California, and this gold, I mentioned we took an example look at leaf gold a few seconds ago. This is crystalline gold, and you can see the triangular shapes there that the gold has. This is basically a shape where it's like a pyramid on the top and a pyramid upside down on the bottom. It's a diamond kind of shape. It's actually the same kind of shape that diamonds crystallize in, and you recognize the diamond shape on playing cards, only this is of course that diamond shape in a full 3 dimension. But this kind of specimen, the guy who found this, he found several specimens with it and made a lot of money, because this type of stuff, this crystalline gold, sells for much more than the gold value of it. It sells to collectors and stuff who prize this sort of material. Now, the gray-white kind of material is quartz, as I mentioned, is very commonly associated with gold. The rusty red-brown is iron. So this it looks like rust because, well, it's the same thing as rust. It's iron oxides. That's what rust is made of. So this is basically some rust, some quartz, and some really beautiful gold. Now here's another very valuable specimen. This is gold, but it's in a very fine dendritic type of a shape. I mean, literally, these little pieces are just a 1/16 or a smaller of an inch long, and they're paper thin. You could take this gold and just mash it up because it's thinner than foil. Yet this is also a piece with very high value because of its crystalline nature. And the white material here is not quartz, as you might guess. Instead, this white material is a zeolite. It's a different kind of a mineral. And the green mineral in the background is chlorite. And at this deposit, which is about 30 miles from Reno in Nevada, is a unique kind of a deposit of gold in a zeolite. And yet, as I mentioned, gold is mostly found in quartz, or at least a lot of times it's found in quartz. And here's a few examples of quartz filled with gold that a guy found with a metal detector. The one on the far right is iron stained, and so has that rusty orange kind of color. And the others are whiter versions of quartz, purer quartz, that have gold shot through various little cracks and crevices in the quartz. And this is just how it formed. Literally, the nature of how gold deposits like this form is that often the late in the life of the formation of the vein in the rock, I mean, literally, these form from hot waters that have gold in them flowing through cracks or faults in the rock. And as it forms, usually the quartz is laid down originally, and then late in the life of this formation of the vein, the gold is injected into the system, and so it tends to fill little cracks and crevices like this. Here is another example. This is thinner, more leaf-like gold, but also injected into cracks and crevices in the white quartz. This is from the Mother Lode country in Northern California. Now, if gold goes through the quartz and the quartz is fairly solid, it's not too cracked up and messed up, you can actually saw these gold quartz specimens, and they actually take this material and cut and make jewelry out of it. And if you look closely in a lot of jewelry stores, they will put material like this, of course, not just cut into slabs like this, but they will take this material and cut and polish and make a gem out of it and put it in a ring or a pendant or something like that. Now, sometimes, like I say, the rock is very fractured, and as you can see in this piece, there's gold all through white quartz, but the quartz is so fractured that you could probably take this piece with your hands and break it up, although it might be more difficult than it looks. It's very highly fractured, this quartz, this white quartz is. But that is gold shot all through that quartz, filling in all the little cracks and nooks and crannies that were left toward the end of the formation of the vein. Here's an actual bit of quartz still in place in the vein in the side of a mine. This kind of stuff can be found with metal detectors, and it can be very rich and really worth a lot of money. And people who find stuff like this definitely make a lot of money doing so. Now here's a specimen. This is from the Philippines. The last one, the gold in the vein in place, was from Northern California, from the California gold country. But this piece is from a quartz vein in the Philippines. And you can see the gold shot through it, kind of, again, occupying the little spaces in the little holes in the quartz. Here's a piece that was found in Arizona. This piece was found with a metal detector, and you can see the blue on it. The blue is copper mineralization, and it's not unusual that a quartz vein that forms with gold will also have some other metals with it, and sometimes those other metals include copper. And if the copper minerals oxidized like the iron did in the other example that I showed you, the copper will oxidize and form usually blue and green kinds of stains instead of the orangey red, brick red kind of color that you expect from rust. Now here's a couple of specimens of gold ore, natural gold ore, from a place called Goldfield in Nevada. And Goldfield was very famous for producing large amounts of super rich material like this. A lot of this material has more than an ounce of gold in a pound of the rock. And you can see the gold all shot through here. The gold is actually in very tiny pieces, even though you can certainly see its coloration there in the rock. Here's a chunk of gold-bearing quartz from Australia. This was also picked up with a metal detector, and the piece originally was completely covered with that rusty red orange kind of color that you see on the side of the rock. The rock was completely covered with that because it was covered with this clay that had this color. But the guy who found it, the metal detector sounded off, and he struck it with a hammer, and sure enough, there was the metallic gold on the inside. You can see it on the lower left of the specimen there. Now sometimes gold is very fine. I've shown you a lot of specimens that have huge amounts of gold in them. The last one, had some gold. It's still pretty rich rock, that chunk from Australia. This piece is from Russia, and you can see that the gold is just kind of like smeared on the side of the rock. It's not very big pieces. And in fact, honestly, a lot of gold ore is mined today that has, in fact, almost all gold ore mined today has less than a half an ounce of gold in a ton of rock. And you can think about that for a minute. Think how small a half an ounce is. Think something like maybe a 50-cent piece. It weighs more or less around a half an ounce. And then compare that to a ton of rock, which would, be a huge amount. So, in most gold mines, work rock that contains less than a half an ounce per ton of rock. Some of them working on 1/10 of an ounce, some even a few hundredths of an ounce per ton of rock. So it's unusual to have the super rich specimens that I've been showing you here, but ones like this that have just a little bit of gold in them is more common. Here's another piece from Canada that has just a few little specks of gold in it. And you can see if you look closely in the rock, there's a few little golden specks there. And to be honest, this is good, rich ore, even though it has just a few specks in a hand specimen like this. If you added up all those little specks in a ton of rock, well, then you might have an ounce or so of this gold, the little specks. And an ounce of gold in a ton of rock, well, an ounce of gold, I'm recording this, is just shy of $1,300 US. And so, $1,300 in a ton of rock is pretty good. And in fact, in all honesty, most mining operations, the cost to mine and extract the gold that's in a ton of rock, it varies from anything from maybe $15 at the very cheapest up to $100, $150. And so you can see, even if it cost you $150 to extract all the gold in a ton of rock, if you had more than $1,000 worth of gold in that rock, in that ton of rock, then you would be doing very well. And a lot of mines produce many, many hundreds of tons of rock a day. Some produce literally, the ones that run on the big trucks and a very large grand scale can produce tens of thousands of tons of rock in a day. So, they may only make $10 or $20 or $30 a ton, but by processing 10,000 tons a day, they're doing pretty good. So here is what really a lot of common quartz looks like. And this is probably decent ore, although I don't know what the testing of it revealed. But this is from the Mother Lode country in California, in Mariposa County. And you can look at this rock and see it's stained rusty colored from iron present in the rock, and it's stained black from manganese. And you don't really see any obvious gold. There's probably a few specks here and there spread through the rock. But like I say, a ton of this rock may be well worth processing. And so, just because a rock looks like this and you don't see a lot of visible gold, that doesn't mean you haven't made a strike of valuable gold ore. It sometimes doesn't reveal itself very easily, and a test is necessary to determine how much gold is in the rock. The other thing that people do is if people see this white vein quartz, and a lot of white vein quartz doesn't have enough gold in it to be worth processing. Just because you find some white quartz in a vein, it doesn't mean it's particularly valuable. The truth is that quartz is made of silicon and oxygen, and those are the two most common elements in the Earth's crust. So if you put together the two most common elements, you end up with quartz. And that really, by itself, so quartz is pretty common. In fact, it's probably the most common mineral on the surface of the Earth. And just because it occurs in a vein doesn't mean it's rich with gold, but sometimes it is. Now, I've shown you mostly pieces of quartz with gold in it. And now we're going to take a look at some other things that look a little bit different. This is some super rich gold and silver ore from Nevada. This is actually from the Comstock Lode up at Virginia City in western Nevada. And the dark gray minerals are a combination of various base metals, such as zinc and lead and maybe a little copper in there. And those are valuable in their own rights, but this ore, the white, is quartz, and it has quite a bit of silver and gold in it. And so this ore, there was huge amounts of this ore extracted in the old days up at Virginia City, and a lot of money made by taking the gold and silver and sometimes the base metals out of it too. Now this is the kind of ore in perhaps one of the richest deposits on the entire planet. This is from the Witwatersrand in South Africa. This is the South African ore that was mined for years. It literally is what geologists call a conglomerate. Those rounded pieces of quartz were once pebbles in a gravel. and the gravel had gold in it. And it was eventually buried and heated, and over time, the heat and pressure actually moved the gold around a little bit in that gravel, but it also turned the gravel into a solid rock called a conglomerate. And this material was mined and a lot of money made off of that. For Hi, my dear. I'm recording a thing right now, so uh, okay, I'll be another 20 minutes maybe. So this is a very special kind of ore called a conglomerate, and this is what they produce in South Africa. South Africa has produced tremendous amounts of ore and gold within the last, I think they started mining it seriously in the 1880s or something like that. And they still mine it deep underground in super deep shafts. This type of rock is called a conglomerate, and you can see the rounded pieces. Those are quartz. The rounded pieces were once pebbles in a gravel. This was a gravel bed, and the gravel bed had gold in it. And it was eventually buried and put deep, deep underground and subject to heat and pressure. And was so much heat and pressure that the gold that was actually in the gravels kind of moved around a little bit and redeposited. But there's certain layers of this conglomerate in South Africa that are rich with gold, and miners dig this out in huge amounts and process it and extract the gold. And like I say, since the 1880s, the country of South Africa mining ore that looks a lot like this has produced tons and tons of gold. This is another unusual type of ore. This is the kind of ore that they mine in Nevada at the Carlin type mines. You can see it doesn't look like much of anything. It just looks like an ordinary rock, except that it contains a little bit more than 1/10 of an ounce of gold per ton. And they didn't discover these deposits. They found a few of them in other places in Nevada beginning in the 1930s, but the Carlin trend, the Carlin area where so many millions of tons of this material has been mined and so many tons of gold has been produced, wasn't actually discovered until the 1960s, because prospectors in the 1800s that were all through here didn't recognize this as being gold ore. There's a couple of problems with it as being a gold ore, why they didn't recognize it. One is if you were to crush this rock and pan it, which is what old-time miners commonly did to test their ore, they would crush down a sample and then process it in their gold pan to see what the heavy elements were. If you did that with this material, because the gold is literally microscopic in size, the pieces are teeny tiny, you wouldn't have anything in your pan. And so even geologists that went looking for this, it took them years to figure out where this stuff was. Once they figured it out, though, they kind of got the hang of it. And another way of testing that was common in the 1800s is testing by what they call a fire assay, where they literally put the material in, they crush it up and put it in with a flux that melts the whole thing and collect it into a lead button and then collect the gold out of the lead button. That process does show, it shows it perfectly well that it's a gold ore, but no one from the 1800s ever paid to take a sample of this and crush it down and process it by fire assaying. But anyway, this is something that is a very rich ore, and a lot of mining companies mine tens of thousands of tons of this every day. Here is another unusual high-grade gold ore. It does have some sulfides in it. You can see the metallic-looking material and minerals in some of these pieces of rock. But this is a special gold ore from a volcanic deposit at Goldfield. I remember I showed you the little specimen of Goldfield ore that had the visible gold. Well, even though this doesn't have a lot of visible gold in it, it does contain quite a bit of gold. And it was very rich, very high-grade ore that was mined at Goldfield, Nevada. And actually, Goldfield produced about 5 million ounces of gold over its history between its discovery in the early 1900s and about 1950. Here's another unusual type of gold ore, and in fact, there's a story with this. This material was mined in a mine in the 1960s, and underneath there was a layer of this dark-colored, rusty-colored material, and underneath it was some rich copper ore. Well, they mined this dark, rusty material and threw it away in the dump because they wanted to get to the copper ore that was underneath it. No one bothered to test this stuff and find that it was rich in gold. And in fact, it's what's called a gossan. This is a gossan type of material. It is basically pyrite or iron sulfide, which is also called fool's gold. And eventually, after it rusts and decays and decrepitates and everything, it ends up like this. But the gold is still in it. And so there was originally some gold in it, and there still is. And yet geologists who mine this stuff and miners took this material from a mine in the 1960s and threw it away, not knowing that there was gold in it. They threw it away to get to the copper that was underneath. So here is that mineral I just mentioned, pyrite. This looks yellow, it looks metallic, but it's a perfect cube, but this is not gold. This is pyrite. It's a mineral that's a combination of iron and sulfur. And it does make some good specimens. A beautiful specimen like this, you can see the price it was for sale for was $550. So, it can have value as a pretty mineral specimen. And sometimes it even has gold in it. And it's often associated with gold ores. So just because you find fool's gold, pyrite, doesn't mean that you're a failure, because sometimes they occur together. And in fact, sometimes it's even hard to tell them apart. Here's a specimen. You can see it has some yellowish, greenish kind of colored mineral in quartz. This is a quartz vein material, and yet this mineral is pyrite. If you look closely, you can see some cubic shapes, some squares, like the example we were just looking at. You can see some squares in this specimen that show that yes, it's not gold, it's pyrite. And yet gold and pyrite often occur together, and sometimes there can actually be little teensy tiny specks, dust literally, of gold inside the pyrite crystal. Here's some more examples of that cubic shape. You can see the rusty brown. Now, this is what happens when the pyrite oxidizes. You remember I showed you the gossan material that was dark and rusty brown, and this is the same thing, only these specimens that you can see have retained the cubic shape of the original pyrite crystal, whereas the gossany material that we looked at a few seconds ago, a little bit ago, did not have that nice cubic shape to it. But it because it's iron and sulfur, when it's exposed to air and water, it will rust just like iron metal. And basically the sulfur comes out of it, and what you're left with is the same thing that you have on the surface of a rusty old nail. It's iron oxides, a combination of iron and oxygen and a little bit of water. And like I say, sometimes it's hard to tell because the gold and the pyrite occur together. Here's a specimen where the pyrite is partly rusted. You can still see a little bit of the yellow-green kind of color to some of it, but you can also see the bright yellow unrusted gold that's associated with it. So sometimes, just because you find a piece of pyrite, it doesn't mean that there isn't gold with it as well. Another thing that fools miners is this stuff, and I got a better picture for it. This is what's called a Telluride mineral. And here's a close-up of Tellurides. This is a combination of gold and the mineral tellurium. It's a mineral called calaverite, and it sometimes fools miners because miners would see this and think, oh, it's just some sulfur mineral and not worry about it. And yet, these little crystals that you see are at least more or less about almost half gold by weight, although they usually contain some silver and some other things too. But there's a considerable gold just in that calaverite, and so if you find this type of stuff, then it can be very valuable. But it often fooled miners, and here's some examples of calaverite in ore from the Cripple Creek district in Colorado. This was something that the miner fooled the miners at first, but they quickly learned that this tellurium is a natural combination, or this calaverite is a natural combination of gold and tellurium, and that the gold can relatively easily be extracted from it. Here's another sample from a mine in Montana that has it has a little bit of telluride in the vein. It's quartz and calcite, which is the white material there. Now, this is a specimen from Nevada and shows a little bit of copper. Now, one of the things I wanted to point out with this is that it doesn't look, just to look at this picture with your eye, you don't really see any obvious gold. But if you take a magnifying glass and look very carefully at the rock, at some of the little cracks and crevices, sure enough, there's little pieces of visible gold in this specimen, and some of them are actually right in and around where the copper is. So a lot of times the gold in gold-bearing veins can be very small. It isn't always big and coarse like the first pictures I showed you. Sometimes the gold in a quartz vein is teeny tiny and hard to see without magnification. Here's another specimen from Goldfield. Like I say, that district in Nevada that produced about 5 million ounces of gold. This is another example of high-grade ore from Goldfield. It has some various sulfides in it, some of which they're pyrite that's rusted, and you can see the rusty color there. But the gold in this is very, very, very fine. It's hard to see, but yet this district, like I say, produced about 5 million ounces. And of course, Carlin, the gold is even too small to see with a handheld microscope. It takes a more powerful microscope to see the gold in that Carlin ore. Now, gold veins can occur right in the rock. Here's an example of a little bit of a gold vein that was right in a road cut, and I took a picture of this because the vein cuts right through this road cut. Sometimes all you see, the expression of a vein just may be a pile of rubbly quartz like this, just a pile of loose quartz that's eroded and dropped off a vein that's buried in the gravel inside. If you were to dig down here, you would certainly hit the quartz vein that is the source of all this quartz rock, and this vein does contain some gold, not huge amounts, but it did definitely contain some gold. Now, I mentioned that there are mines where they mine tens of thousands of tons a day, and this is the kind of mine. This is a mine in Nevada that I took some pictures of. I got to go visit, and they were literally digging huge truckfuls, and if you were to stand next to one of the big rubber tires here, those tires are about 12 feet tall. They're gigantic. They're taller than you are. So these mines work and extract gold on a very, very large scale. And the amount of gold in the rock is relatively small, but they process huge amounts and they do it at a very low cost. And so they're able to make money mining this low-grade ore on a high-volume basis. Now, there are still mines like this, the 16-to-1 mine in Allegheny, California, that produce some rich ore. They're still out there, and they're still working this mine, and some of the examples that I showed you at the beginning were pictures of ore rich gold ore from the 16-to-1 mine. So, it's still out there, and there's still people doing this, and it's still a worthwhile job. But also, a lot of people find rich gold ore with metal detectors by going through old areas, old mining areas. Here's a beautiful specimen that was found with a metal detector that contains a number of ounces of gold. And the guy who was metal detecting there and ran into this piece, and he was very pleased to find it. Some other specimens that were found by a guy with a metal detector. Pieces of quartz shot through with rich gold ore. Another specimen, beautiful gold in quartz. These pieces have some real value, and this one was also found with a metal detector. Here's a piece with gold shot through it that I found with a metal detector. It's a beautiful piece of quartz with some nice gold in it. Now, sometimes, like my piece where there's not a lot of gold showing, the people, if they want to produce a better specimen, will take and put the quartz in an acid. There's a specific kind of acid that will dissolve quartz but leave gold behind. Now, this acid is pretty dangerous. In fact, it's among the more dangerous kinds of acid out there. So I'm not actually going to mention the name of it. But you can see that this piece, the quartz, has been kind of eaten away, showing the gold that was within it better. And in fact, you can actually eat all of the quartz away and leave nothing but the gold behind if you have enough of that acid. And this is the kind of thing you end up with if you eat basically all the gold out. This was a find with a metal detector in Arizona, and this is many pounds of gold and, of course, many dollars worth of gold. So you can see that finding natural gold can be very profitable, and I hope you enjoyed this presentation, because I'm going to go ahead and throw it back to myself and finish up this video. Okay, so now you've had a chance to see a whole lot of different specimens of gold ore, from super rich stuff with lots of visible gold to other things that just don't look like much and may have cost a lot of people a lot of money that walked right by it because they couldn't recognize it. The bottom line is you really need to sample. Sampling is a critical part of finding gold ore, because just eyeballing it, you might say like the assayer who didn't want to test this stuff and thereby lost out. He lost out on millions and millions of dollars that he would have made if he would have tested it. So testing is important, and one of the ways that old timers used to test was they'd actually crush a sample of gold ore down to powder and then pan it in a gold pan. That's how they would tell. But even that loses a lot of gold. There's a number of ores around that have lots of gold in them. But if you crush it and pan it, you won't see it because it's microscopic or super small. You might never notice it. So learn to see gold ores and recognize things, and learn to sample things that might be, you have any inkling that it might be gold ore, it's important to sample. I hope you've enjoyed this video, and I have one final message for you. So also I want to mention my book, Fistful of Gold. If you have more interest in learning about how to find gold and be successful as a prospector, this is the source that you want to check out. Basically, my book is an encyclopedia of everything you need to know about prospecting, from panning, sluicing, metal detecting, dry washing, to geology of gold, and even how to stake a claim. It's basically everything you need to know about prospecting, and it's available now on Amazon. You just go to Amazon and look for Fistful of Gold by Chris Ralph, and I guarantee you'll find it. Also, I have my own website, and that's, of course, free. And for more free information, just go to nevadaoutbackgems.com/prospect/chrisprospect.htm. That's the URL for it, and it's got all kinds of information about prospecting and mining and the whole thing, everything you wanted to know, including some great history and locations of where you might want to prospect for gold. And finally, if you like this presentation and you want to learn more about finding your own gold, I promise that I've got quite a few more gold, silver, and gemstone videos coming that are on the way. A lot of exciting and interesting stuff, both in the form of live action videos as well as slide presentations. So be sure to click the subscribe button and the notification bell, and YouTube will let you know when I publish new stuff. And hit the like button as well, and feel free to comment or ask questions, and I promise to do my very best to answer any of your questions as best I can. So thanks a lot, and hope you enjoyed this, and we'll see you again soon.